Good morning, Year 7. Today we are going to be classifying quadrilaterals and polygons. Polygons are closed, plane shapes with straight sides. The word polygon comes from the Greek word poly, which means many, and gonia, which means angles. So many angles, which also means many sides, to the shape. A vertex is the point at which two sides of a shape meet. And we can have special names for the types of angles that are made. So we have convex polygons, have all the vertices pointing outwards and all interior angles. So what that means is that the inside angles are smaller than 180 degrees. Okay, so an example of what that might look like. Something like this. Just any polygon, you can have as many sides as you like, as long as all the angles inside are less than 180. Okay, so that would be an example of a convex polygon. However, we have a non-convex, which we also call concave polygons. They have at least one vertex pointing inward and at least one interior angle that is larger than 180 degrees. So this would look like something like this. So I'm going to have the shape pointing inwards and then coming back out again. So this angle in here is what is making my shape concave because it's pointing in. So this is either called concave or non-convex. Okay, next one. Regular polygons have sides of equal length and angles of equal size. So an example, a very simple example of that would be your square, because all the sides are the same length and all the angles are right angles. Okay, but it could also be a pentagon, something with 5 sides, and it would have been all the sides the same length and all the angles are the same. A diagonal is a segment that joins two vertices, dividing a shape into two parts. So you could have, you can draw a parallelogram here, and if you draw from one side across to the other, that's what we call a diagonal, and it is dividing that shape into two parts. The next thing that we have here in our booklet is the names that we give to different types of polygons. We already know that a 3-sided shape is a triangle and a 4-sided shape is called a quadrilateral. Some of the lesser known ones are listed here and they're good ones to know. So a 5-sided shape is a pentagon, 6 sides is a hexagon, 7 sides is a heptagon or a septagon, either name is acceptable. 8-sided shape is an octagon, 9-sided shape is a nonagon, 10 is a decagon, 11 is an undecagon, and 12 is a dodecagon. Now let's talk a bit more about quadrilaterals. We have many different types of quadrilaterals. The word quadrilateral means that we have 4 sides, but there are lots of different types that can come out of that. So if we have two pairs of adjacent sides equal length, remember that adjacent means from a point that arm and that arm are the same length, and from this point that arm and that arm are the same length. So if we have that, then we have ourselves a kite. The properties of a kite is that we have two pairs of adjacent sides are equal in length, one diagonal bisects the other diagonal, and one diagonal of the kite bisects the opposite angles. The diagonals of the kite are perpendicular. Okay, so there's a lot of things in there about diagonals. Let's try and draw some of that on there. If we have a diagonal going across the shape here and across the shape there. Okay, so there's two diagonals. It says one diagonal will bisect the other. Now you can see that the long one here, it hasn't been cut in half. But the shorter one, this side, should be equal to that side. Or that length. One diagonal bisects the opposite angles. Again, that's going to be this angle and this angle that are the same. That angle and that angle are the same, but not the ones on the bigger corners there. The diagonals of a kite are perpendicular. That means that these are all meeting at little right angles in here. Okay, if our shape has one pair of parallel sides, it means that we have ourselves a trapezium. The traditional way of seeing a trapezium is to have a pair of parallel sides and the two slopey side ones. But it can have lots of different variations. In fact, all of these ones down here, following down on the right-hand side, could also be classified as trapeziums because they all have at least one pair of parallel sides. So a parallelogram has the one pair of parallel sides, but it has actually got a second one. So we have two pairs of parallel sides. The opposite sides are equal. The opposite angles are equal. So this angle and this angle will be the same. That angle and that angle would be the same. The diagonals of the parallelogram bisect each other. So if we draw these diagonals on here, these ones will be the same size and those ones will be the same size. Okay, next, going down the list, we have got, let's go over to the rhombus. So if we take our parallelogram and we make all of the sides the same length, it becomes a rhombus. So a rhombus has opposite sides are parallel. All of the rhombus sides are equal in length. Opposite angles of the rhombus are equal in size. So that's the same as the parallelogram. That one and that one, that one and that one, they're equal in size. The diagonals of the rhombus bisect the angles. So when I draw these diagonals on here, these angles have been cut in half, those angles have been cut in half, all of them going around the outside have been cut in half. The diagonals of a rhombus bisect each other, which means this side and this side are the same length, that side and that side are the same length. And they're also perpendicular, which means that we have right angles in here again. Okay, if we go back to our parallelogram and we make all of the angles right angles, we get a rectangle. So a rectangle has opposite sides of the rectangle are parallel, opposite sides of the rectangle are equal in length. All angles are 90 degrees. The diagonals, if I draw them on there, are equal in length, and the diagonals bisect each other as well. So you see, the further we go down this list, the more properties the shapes are getting. Finally, the square has the tightest restrictions of everything. The square has all sides equal in length, and all angles are right angles. So it has opposite sides are parallel, all sides are equal in length, all angles are 90 degrees, diagonals are equal in length, diagonals bisect the vertices, diagonals bisect each other, and they are perpendicular to each other as well. Okay, so let's have a look over here at our examples. Example number 1. State the type of polygon, state the type of polygon and state whether it is convex or concave. Well, she says non-convex. So we want to name this, which means we need to know how many sides it has. So if I count them up, there is 1, 2, 3, 4, 5 sides. And if you look back to our list way back here, 5 sides is a pentagon. So this shape is a pentagon. And because all of the angles are pointing outwards, we call this a convex polygon. Question 2. Is the above polygon regular or irregular? Regular means that all the sides are the same length and all the angles are the same size. And we can see that, like if you look at side 1 and side 2 here, side 2 is much, much longer. We also have some acute angles and we have things that look like obtuse angles, so the angles aren't the same size. So this is what we would call an irregular polygon. Question 3. State the type of each quadrilateral given below. So this one, does it fit any of the properties in that big table that we looked at? Well, we can see we've got 1, 2, 3, 4 sides, but we don't have any equal sides, we don't have any equal angles, we don't have any parallel sides. So the best we can do is call this a quadrilateral. And then talk about whether it is convex or non-convex. Because we have this angle pointing in, this would be a non-convex or concave, if you prefer, quadrilateral. Shape B, because it has a pair of parallel sides, just one pair, and those slopey ones on the edge, this is a trapezium. Okay, it would also be convex because it is all pointing outwards. So time for you to practice. You're going to go to page 47 and 48 of your workbook.